Hey, what's up guys, welcome back to the channel. In this particular video, I will explain the problem given a linked list of 0, 1s and 2s. Sort it. Well, that's interesting. The problem title itself is the problem statement. It's basically saying that you are given a linked list of n nodes where every node can have value either 0 or 1 or 2. And the task is to segregate 0, 1s and 2s linked list such that all 0s get segregated to the head side. Then I have every 1s in the middle, then I have 2s at the end of linked list, right? So one example is given here. But before that guys, make sure you watch this video till the end because this problem is frequently asked by companies like Amazon, Microsoft, MakeMyTrip, etc. So now talking about this example, so we have to segregate 0, 1s and 2s, right? So first I need to get every 0, so I have 0. After this I need to get every 1s, right? So I have 1, then I have again 1, right? After this I need to get every 2s in the end of the list, so I'll write 2, then 2, then 2, then again 2, then 2. So this is how we can solve for this example. Now I hope you guys have understood the problem statement. So let me talk about the solution. Okay, so here I have written the same example as given in the problem statement, and first of all let me try to solve this example and then I will talk about the intuition, right? So see, according to the problem we have to segregate 0, 1s and 2s list, and we have to get every 0 first, then we have to get 1, then we need to get 2, right? So I have 0 1s, right? So I'll write 0. After this I have 1 2 times, so I'll write 1 and 1. After this I'll get 2 how many times? 5 times, so I'll write 2, then 2 again, then 2, then 2 and then 2, right? Now I want you guys to observe one thing here. What actually I'm doing, I'm counting the frequency of 0s, 1s and 2, and these many times I'm first appending every 0, then every 1 and then every 2, right? So now how many times I have 0? So I have 0 1 times, then I have 1 2 times, after this I have 2 5 times, right? So these many times I have to append these values to the list, right? So this is basically an answer list. Now this is something that can help us to get the approach, right? So I hope you guys are clear with the intuition. Now talking about the approach, so all we need to do is just count the frequency of these like 0 1s and 2s, and after this append every 0 to the answer first, then 1 and then 2. So let me show the pseudocode now. Okay, so this is something that is going to help us to implement the solution. First of all, I need count 0, count 1 and count 2, right? After this we are going to traverse the whole list, and then while traversing, if my head data is equal to 0, then I'll increase count 0, and if it's equal to 1, then I'll increase like count 1, and similarly if it's equal to 2, then I'll increase count 2. At last I will have every possible frequency of count 0 1 and 2, right? So 0 I have 1 time, then I have 1 2 times, then I have 2 5 times, right? I'm talking about the same example that we have in the previous page. Now once I have done this, so all I need to do is I need to create an answer list, right? So initially my answer list is equal to a dummy node which is -1, and my answer pointer is going to point to each like the end of the answer list every time, right? So initially it's pointing to this dummy node, and what I'll do is first of all I'll append every 0 to the list. How many times? Count 0 many times. So I'm starting a loop for I equals to 0 to count 0, right? Or I smaller than count 0, not equal to count 0. I hope you understand this particular loop. So what I'll do is I'll like append 0 element to the end of this particular list one time. So I'll say that okay, I have 0 here now and I have pointer here, right? And pointer is now pointing to this value. So see here, I'm creating a new node, right? After this I'll start a loop for I equals to 0 to count 1, and this way I will have 1 appended 2 times, right? So 1 appended 2 times, so I'm done with 0 and 1, and now the pointer is pointing to this value. At last I just need to append 2 as well in a similar manner, right? So I will have 2 then 2 then 2 then 2 and then 2, and at last pointer will be pointing to this value. So once I'm done with these two steps, so all I need to do is I need to return answer, right? But before that I need to make this value like make the next of pointer pointing to null value, right? So that I can have a complete linked list. Now this is a complete linked list, right? And see here, while returning the answer we have to avoid this dummy node. So I'll say that okay, return answer.next, right? Return answer.next. So this is how we can solve the problem. Now I hope you guys have understood this particular approach. But talking about the time complexity of this approach, so see here, the time complexity of this approach is not more than O of n, right? Because we are traversing O of n nodes, and even the sum of these count is also equal to O of n, or smaller than like these count individually are going to be smaller than or equal to the length of this particular list, right? So the worst case is I can have a list of 2 only. So this way I can have count 2 equals to the length of linked list. So these 3 loops are not going to run more than O of n here, right? So this is about the time complexity. What about space complexity? So space complexity for this approach is going to be O of n again, right? The reason is we are creating like new node here, right? So you can see here, right? We are creating n new nodes here in order to get the answer list, and apart from these we are creating a dummy node as well. So the space complexity is O of n, right? Now we can write another approach which is going to optimize the space complexity to O of n. So let's see how we can do this. Now talking about the approach, so first of all let me remove this particular stuff so that I can get some space to explain. Now second approach is really interesting, and I want you guys to understand that particular approach very carefully, right? So let me start. Now see, we have the same example, and for this example what we will do is we will try to like make 3 lists. First is 0 list, then we have 1 list, then we have 2 list, right? 2 list, and the concept is going to remain same like we made the answer list here, right? how we made the answer list? We have answer which is initially equal to -1, then we keep appending the value and move the pointer. So I need 3 pointers here. First of all, I will have a 0 pointer, then I will have like 1 pointer, then I will have 2 pointer, right? So what I'll do is I'll start traversing the list. First of all, I have 1, so I'll append this 1 to the 1 list, but initially we have -1 in this list, right? So now first of all, I'll append 1 to the 1 list, so I will have 1 here, and now the 1 pointer is pointing to this value, right? And 0 pointer is currently pointing to this value, and 2 pointer is currently pointing to this value. After this, I have 2, so I'll append to the 2 list, and then I'll move this pointer. After this, again I have 2, so I'll append to the 2 list and move this pointer. Then I have 1 again, so I'll append to the 1 list and move the pointer. After this, I have 2 again, right? So I'll append to the 2 list, then I will move the pointer. Then I have 0, so append to the 0 list and move the pointer. And after this, we have again 2, so append to the 2 list and move the pointer. And similarly, I have 0 again, so I'll append to the 2 list and then move the pointer. Now see here, we have got our 3 lists, right? And after this, we just need to point the pointer of these values to the null, right? So that these becomes a complete linked list here. And this is also equal to null. Now all we need to do is we need to append these 2 lists at the end of each other. First we have 0 list, right? So whatever is my 0 pointer, okay, don't point to null, don't point to null. There is a reason. Only this value is going to point to null because I will have this 2 list at the last, right? I hope that makes sense to you, but let me explain. So I have 2 pointer here, so I'll say that, okay, now, okay, I have 0 pointer here, my bad. So I'll say that 0 pointer dot next is equal to 1 pointer, which is 1 pointer, actually it's 1 list, so right? So I'll say that 1 list dot next, right? So I'll say that 1 list dot next. What it will do is it will make the next of this particular value to this value. So I'll have 0, after this I'll have 1, then I will have 1, right? So you can see that now these 2 lists gets linked, 0 list and the 1 list. I hope you have understood this thing. Similarly, we are going to link 1 list and 2 list as well, right? So I'll say that, okay, 1 pointer is basically pointing to the end of 1 list, right? So I'll append like the head of 2 list to the end of 1 list. So I'll say that, okay, 1 pointer dot next is now equal to 2 list dot next. Why I'm writing 2 list dot next? Because I know the first node is pointing to a dummy node, right? So I need to get the next element of 2 list. Now this 1 will point to this 2, and now I have the whole list. See, I have 0, then 1, then 1, then I have 2, 2, 2, 2, 2, and at last this is going to point to null, right? So this is how we can get our answer. And see, we are not creating any new node here. We are just going to use these particular nodes, right, in order to get the answer. The only new nodes we are creating for dummy nodes, and this is not more than 3 because we have 3 different lists, right? Now I hope you have understood the approach. So let me try to write the pseudocode now. Okay, so it's taking time to open the page. Let me move to this particular page. Okay, now how we segregate list, I think concept I have explained to you. All I need to do is now I'll just explain you, right? So I'll first have a 0 list, right? And after this 1 list, after this 2 list, and all these are going to point to like node -1 initially, right? So I have 3 lists, 0, 1 and 2, and initially these are pointing to nothing but -1, which is a dummy node, right? And now what I'll do is I'll traverse the list. So I'll say that while my head is not equal to null, head is not equal to null, and after this, inside this, what we do? We do head equals to head dot next, right? So I think this is something that I have forgot for the previous page. See here, while traversing the list, we have to do one more step, which is head equals to head dot next. If you don't do this step, then it is going to give us a time limit exceed, right? So I'll say that head dot next. Okay, now coming back to this part again. So if my head is equal to 0, if my head data is equal to 0, so what to do in that case? See, first of all, I need a 0 pointer, 1 pointer, and 2 pointer. So I have 0 pointer, then 1 pointer, then 2 pointer, right? Okay, so whenever our head data is equal to 0, so I'll say that my 0 pointer dot next, my 0 pointer dot next is equal to head, right? And after this, I'll say that 0 pointer will move to next. So 0 pointer equal to 0 pointer dot next. Just after this, if my head is equal to like 1, else if my head data is equal to 1, in this case I have to do the same thing for 1 pointer, right? So I'll say that 1 pointer dot next equals to head, right? And after this 1 pointer is going to move, so 1 pointer dot next. And then if we have like in else case, I'll do the same thing for 2 pointer. So I'll say that, okay, now my 2 pointer dot next is equal to head, right? And 2 pointer will move to next, so I'll say that 2 pointer equal to 2 pointer dot next. So this is how at last I can have 3 lists, 0, then 1 and 1, then 2, 2, 2, 2 and 2. So I'm taking an example like I'm making 3 lists here, right? And these 3 lists comes from the previous example where we have 1, 2, 2, 1, then 2, 0, 2, 2, right? This was the list which was given to us in the example. Okay, once we have created these lists, then the task is just to append this list to the end of each other so that I can have a complete list of 0, 1s and 2s, right? And at last I have to do 2 pointer dot next equal to null, right? So 2 pointer, 1 pointer, 0 pointer are pointing to the last value, and these lists are pointing to the head value, right? So see, in order to append the end of this particular list to the head of this list, I'll simply do one thing. I'll say that, okay, 0 pointer dot next equal to one pointer, okay, not one pointer here, the head is one list, right? So one list dot next. Why one list dot next? Because see, this is not the starting of one list. The starting of one list is -1, right? Because we have created a dummy node first. Okay, now there are some cases that we need to handle. The first case is if we have 0 and if we don't have one list, and then we have two lists, right? So for this I'll have nothing in the one list, so I'll say that 0, 2 and 2, right? But when we try to do this particular step, then it is going to give us an exception because we don't have any element in the one list. So it will do 0 and then the next will be null, right? And after this we will not be able to append this particular two list. Okay, so I have to handle these cases, but I'm going to explain these cases from the code only. So let me show you the code. This is the code that we have. I have first written the C++ code, then I have the Java code, then followed by the Python code, right? So see how we segregate list. The same concept is going to be used here. I have already explained this. Now after this, these are the cases that we need to handle, right? Let me show you. So if my 0 list is not equal to null, right? Add for that, if my 0 list is not equal to null, and inside this, if my one list is not equal to null, right? So if my one list is not equal to null, in that case I'll do a simple step, right? That 0 pointer dot next equal to one list dot next, and then 1 pointer dot next equal to two list dot next. So this is the simple step that I have explained you, right? Like this 0 pointer is going to point to this particular list, and then 1 pointer is going to like this particular list, right? This is the second list. So this is the first simple step. But what if we don't have this particular list? So what we will do is, in that case I'll point 0 pointer directly to the end of two list. This is what we need to do. So I'll say that 0 pointer dot next equal to two list dot next, right? So let me show you again. So you can see here that 0 pointer dot next equal to two list dot next. In this case 0 pointer will directly point to the two list because we don't have any element in the one list, right? Okay, after this I'll say that 2 pointer dot next equal to null, and then we just need to return 0 list because 0 next is not equal to null. So I'll say that 0 list, return 0 list. But what if we don't have any element in the 0 list? So this is again one possible case. Let's say I don't have any element in the 0 list. I don't have any 0 list. So let's say I don't have this 0, right? So in this case I need to get 1 1 2 2 2 2 2, right? And at last I need to return the head of one list, right? So I'll return the head of one list, which is one list, right? So you can see here as well, if my 0 list is equal to null, only if only in that case I'll come to this particular part, right? And I'll simply return one list in that case. And even if my if my one list is equal to null, in that case I'll simply return two list, right? So I hope you have understood the approach that we are going to follow, right? And same I have written the code in Java as well, and you can see the Python code as well. So this is all about this video. Now you can see here how we have optimized the space complexity, right? So now I hope you guys have understood this particular solution as well. And if you guys like the explanation, then you can hit the like button. Thank you.